Okay, we can find here the unit vector of AC. So to find the unit vector of AC, we do XC minus XA. So it will be minus 0.96 along I, plus 0.5 along J, and minus 0.72 along K. So, and we divide, of course, by the magnitude, which is radical of 0.96 square plus 0.5 square plus 0.72 square. In this way, we express vector TAC function of the magnitude, because you know that TAC vector is magnitude of TAC times the unit vector. So I will get that TAC vector is minus 0.738 TACI, where this one is the unit vector component along X. For J, if I calculate J component of the unit vector, it will be equal to 0.384, and I multiply by the magnitude TAC along J, and minus, this is the component along K for the unit vector, so minus 0.554 TACK. So now I obtained vector TAB, function of ijk. I know it completely because look, the magnitude is given. So I just multiply the unit vector by 732. While for TAC, I can express the vector function of the magnitude, which is TAC unknown. Okay. Now, once I have expressed all my vectors, okay, all I have to do is to do their summation and replace them in the vectorial relation. So the main vectorial relation is here. It is R equal to TAB plus TAC plus P. Okay. So now, if we replace, look, for them, they didn't pay attention that Rx should be in the negative. So they put it just as Rxi. Now we put minus FRI. This is why they will get a negative result. Why we are sure that F resultant will be from A to O, not from O to A? We directly put FR like this in the negative X. Because look, both TAB and TAC has negative X component, while P has a 0 component along X. So of course, since R is their summation, it cannot have a positive X component. It should have a negative one. If you didn't pay attention, it's not a problem. You can put it as they did. They put it's equal to Rxi, and they will get a negative value for Rx. Okay? So now, the final step is to replace. Okay? So since once I have the expression of each vector, all I have to do is to replace in my equation. Okay? Replace in my equation and compare. What do I mean by compare? Here you have a vectorial relation. You have two sides. One side at the left you have Rxi, and at the right you have three terms along I, along J, and along K. So first, by comparison, here we will see together that since they didn't ask for Rx, they just asked for the magnitudes of TAC and P, it is enough to compare along J and K. But I will do it for you, okay? So if they ask you for Rx, you can find. So first, you compare, you say, I will compare along I. This means what? I look at my equation, okay? At the left side, what do I have along I? I have Rx. Oh, if we are following our method, I have minus FR, okay? It is equal to what? It is equal to from the other side, okay? The component along I is this one. It is minus 576 minus 0.738 TAC, okay? So if I just write it, I can put that Rx is minus 576 minus 0.738 TAC. And look, it's very direct. You can directly see it that Rx is negative, okay? While FR is positive because FR is plus 576 plus 0.738 TAC because you have here a minus, okay? Now, to be able to get Rx, you need to find TAC. So I should go to the other equations. The other equations are comparison along J and K, okay? If I write comparison along So let us compare along J now. Compare along J. From the left side, do you have any component along J? You just have a component along I. So you can say that here it is 0. Okay, so 0 equal. From the other side, what is the component along J? It is 348 plus 0.384 TAC minus P. So the comparison along J will give you this relation, this one. Okay, it will give you a relation between TAC and P, but it's not enough because I didn't yet calculate TAC or P. So I need an additional equation. This is why here I started by the comparison along K, because it will give you directly TAC. You can see it directly from the equation, because look here, in Y component you have two unknown, TAC and P, while in K component you just have unknown TAC. So the best idea is to start from here. If you compare along K, so by comparison along K, what do you get? You get that 288 minus 0.554 TAC equals to 0. Okay, so by comparing along K, you get this result here. That 288 minus 0.554 TAC is 0. So you deduce the value of TAC. And once you find TAC, you can replace back here in the comparison along J. So you get your second unknown, which is P. And also, if you want to find FR, also you replace back here and you get FR. Okay, so it's a system of 3 equations with 3 unknowns, which will allow you to find all the unknowns in your problem. Any question on this problem?
Best doctor, when is your office hours?
Whenever you want. You just tell me I have questions. So we open Zoom, or if you prefer to send your question by WhatsApp, also I don't mind. So as you like.
Okay, thank you.
Welcome. Any question on this? Okay, so we continue doing the review problems next time. Thank you.
Thank you, doctor.
Thank you, doctor.
Thank you, doctor.
Thank you, doctor.
Please try to practice the remaining problem, okay? Because if you don't practice, and it's hard to understand, try to do them by your own, so you will understand better when we solve them together, okay?
Yeah, sure.
Thank you, doctor. Bye.
Bye-bye.
Have a good day.